Hello everybody, and welcome to the video for section 14.2. This is the section on sampling and gathering data, and this will now continue the trajectory we started in section 14.1. To motivate what we're going to do here, consider this example. You are the governor of Kansas and you want to know something. The exact example here doesn't matter, but you want to know how the public feels about legalizing marijuana. So you ask your statistician what they think about this, and he tells you, look, I ran a survey, and according to the survey, 67%, so two-thirds of Kansans support legalizing marijuana, while 33% oppose it. And the survey received answers from 290,000 people, which I don't know if you are used to dealing with sample sizes or not, but 290,000 is a humongous amount of people. Okay, so there's no issue with sample size here. So 67% of that almost 300,000 people supported legalization, and a third of that sample opposed it. So if you are the governor, my question to you is, what do you do with this data? So a statistician has presented you data. It seems to imply that the majority of your constituents would like to legalize marijuana. Does this mean that you as a politician, if you are trying to represent your people, does that mean that you as a politician should now support legalization? Well, if you're this governor, of course, this is Kansas we're talking about, so this data should appear suspect to you. I highly doubt that two-thirds of Kansans want to legalize marijuana, but I don't know. This might be true. But I imagine that you as the governor would have several follow-up questions for the statistician. In particular, anytime somebody presents you data like this, you should ask, where did that data come from? Who exactly are these 290,000 people, and how did you get their answer to that question? Okay, so where's this data coming from? If you don't know where the data came from or how the data was gathered, the data might not mean anything. You might not be able to make any inferences at all from this data. So following up on that, this is the question that we're going to answer in this section. What is a good way to take a sample? Did this dude right here, this sample of 290,000 people, did he take that sample in a good way or a bad way? If he took the sample in a good way, then I suppose you should take this data seriously. But if he took the data in a bad way, then who knows what this data means? It might not mean anything. So how do we take a good sample, and how do we get a sample that's representative of the population that we are interested in? So in this case, how would you take a sample that's representative of the population of Kansas? Okay, so any survey or poll has 3 steps. The first thing you do is sample, which simply means take a group of the population, right? Once you have that group of people, you measure them, where measure is just a catch-all term for literally measuring things sometimes, right? You can measure their cholesterol levels, you can measure their weight, whatever, or you can ask their opinion about things. Yes or no, legalize this, or whatever. So whatever it is that you are interested in, you then measure that inside of the sample. Okay, so why did we take a sample in the first place? Well, because we're interested in our population. So in this particular example here, we are interested in what the population of Kansas thinks about marijuana legalization. Okay, so we take a sample, we figure out what the sample thinks about such a question, and then from that data of the sample, we draw inferences about the population. Okay, so you get your little group of people, you measure them, where measure means whatever it is that you're interested in, right? From those measurements, you then draw inferences about the global population that you're interested in. Okay, so just a bit of terminology here. If your sample is the entire population, you have performed what is called a census. Okay, so if in this previous example of marijuana legalization, if you literally asked every single Kansan, what do you think about marijuana legalization? You have performed a census. A census is a good thing. Okay, if you are interested in what the population of Kansas thinks, it would be nice to ask every single individual in the population what they think. Okay, a census is good. It's just not terribly practical most of the time. If you choose a good sample, you can get reasonably reliable data about the population from the sample. So the sample, if it's chosen well, will tell you essentially what a census would tell you. Okay, a census is what you'd like because that really gives you everything you would want to know. A good sample will hopefully tell you the same thing that a census would have. So in other words, if you asked every single Kansan, what do you think? Legalize marijuana, yes or no? If 40% said yes and 60% said no, if you chose a good sample of that population, you would hope that close to 40% would say no and 60% would say yes. or I may have mixed up those two numbers, but you know what I'm saying. If the entire population is a 40-60 split, then the sample is also hopefully close to a 40-60 split. Okay, so what's a good sample? It's representative of the population and big enough to cover variability. So if your population has a lot of different ethnic groups, a lot of different age groups, income levels, whatever, you need a a sample that's big enough to cover that kind of variability. Okay, in this chapter, capital N will always denote the size of the global population. So in this running example we have, capital N is the size of the population of Kansas. So that's 3 million people or whatever. Little n, so a lowercase n here, will denote the size of the sample. And the fraction little n divided by capital N is called the sampling proportion. So this sampling proportion is trying to tell you how big your sample is relative to the size of the population. So just to make sure you understand this definition, you should ask yourself this question. If you take a census, what is the sampling proportion? So I will let you think about that for a second, and you can of course pause the video if you want to think about that. But remember, in a census, your sample is the entire population. Okay, so you're just asking everybody. So if you take a census, this little n here is actually the same as big N. Right? Big N is the size of the population. And big N divided by itself is 1. So in a census, the sampling proportion is 1. And remember, 1 is the same thing as 100%. So all we're saying there is that in a census you interviewed or measured 100% of the population. Okay, what makes for a good sample? Every member of the population has an equal chance of being included in the sample. If this is not the case, the sample is called biased. So what makes a good sample? It's representative and bigger enough to cover variability. How do you make sure that happens? How do you make sure your sample is representative and covers all the variation in your population? Well, this is how. You make sure that every single member of the population has the same chance as anybody else of being included in the sample. So I have the same chance as you, have the same chance as every other Kansan or whoever of being included in the sample. If that is not the case, so if there are some people that are more likely to be included than others, the sample is called biased. So now we're just going to walk through the various types of bias you can have. Bias is a bad thing. Whenever you have bias, you can be pretty sure that your sample will not be representative or not cover the variation in the population. Okay, so either way, if there's bias in your sample is probably worthless. You probably cannot make inferences based on that sample. Okay, so here's the first kind of bias we can have. It's called selection bias. when the selection of a sample has a built-in tendency to exclude a particular group or particular characteristic within the population the survey suffers from selection bias. Okay, so before I get to that vocabulary there, let me just say, suppose that you've set up a study and it turns out that your study is more likely to include white people than black people. Okay, that's a form of selection bias. White people are more likely to be included, therefore your study has a built-in tendency to exclude other ethnic groups. Okay, that would be bad. Okay, the target population of a sample, or sorry, of a study, is the population to which conclusions of the survey apply. The sampling frame is the population from which the survey is actually drawn. To avoid selection bias, these two things should be the same thing. So here's an example. You are interested in Americans' views on tax policy. You take a sample of 1,000 people and ask their opinion. So maybe you ask them, I don't know, should taxes be raised on the rich or something? Some sort of tax question. In this instance, what is the target population? Well, the target population is the population to which conclusions of the survey apply. You are interested in Americans' views on tax policy. And presumably here you mean American adults, even though it doesn't say that. You know, you probably don't care what a 5-year-old thinks about tax policy. But anyway, that's what your target population is, American adults. You want to run a study that investigates what American adults think about tax policy. So the target population is American adults here. That's the population to which you would like your results to apply. Suppose that after you conducted all of your interviews, you notice that all 1,000 people in your survey have an annual household income of 170 grand or more. What does that mean? That means that you didn't actually pull a sample from your global population. You pulled your sample from a much narrower group of people. All 1,000 people here are what we would call wealthy or perhaps upper middle class, you know, whatever word you want to use here. So in this case, your sampling frame did not match your target population. Your target population was all American adults, but you did not take a sample of American adults. You took a sample of upper middle class American adults. Okay, so you see the difference? The target population is the global population. It's the population about which you would like your results to hold. But notice that with this data set here, with this sample that you took, the conclusions of your survey can't apply to all American adults. The conclusions of your survey can only apply to upper middle class American adults because your sampling frame, the place from which you actually got your sample, is upper middle class adults. Okay, so there's sampling bias here, there's selection bias here. Here's an example where your target population did not match your sampling frame. So people who are rich were more likely to be included than people who weren't rich. Let's move on now to a different type of sampling bias. This is a fairly common type of bias, and the word here, the term convenience, is suggestive. This is sampling that's done by convenience. So you do whatever's easiest or cheapest to gather your data. So in convenience sampling, the selection of who gets to be in your sample is dictated by cheap cost or just ease of selection for the people who are running the study. So for example, just you want to ask people again about tax policy maybe, whatever. And to gather your data, you set up a table right outside of a mall or a grocery store or something, and then you ask people their opinion as they walk by you. Notice that you have done something cheap and easy for you if you are running this study. It's cheap because all you're doing is sitting there, right? You have to bring your own table, I suppose. So the table costs something, but that's it. And it's easy because you're just sitting there asking people who walk by. Okay, so you're going to get sampling bias from doing this. Basically by taking shortcuts, you should not expect to get a representative sample. This will never gather good data for you. Okay, self-selection bias is a type of convenient sampling in which each individual can choose whether or not to be in the sample. So in this case here, we're talking about things like internet polls, call-in polls, internet rating systems. So if you go to buy a book on Amazon.com, it has a star rating. You've probably noticed, right? The people who leave ratings aren't randomly chosen by Amazon, right? Those people who leave ratings choose to leave ratings, and they're allowed to, right? Those people, if you consider those 50 ratings as a sample of opinion, those 50 people who left ratings got to choose to be in the sample. Okay, so it's considered bad data gathering to let people choose to be in the sample. If you let people include themselves, generally you will get people who are angry when you're talking about ratings, right? If you look at a lot of book ratings, there are a lot of 5-star reviews and a lot of 1-star reviews. So you get people who are very angry or very happy. It's just not a good way to gather data. There's no reason to think that letting people include themselves will end up with a representative sample of the overall population. Okay, so here's an example. Suppose you want to investigate whether or not there is public support in Kansas City for a public transit system downtown. And of course, we are interested in this, or we were. I guess they've made their decision by now, but if you're going to do something like this, if you're going to put in a rail system or something, you should probably make sure there's public support of that before you do it. Okay, so to do this, you take a sample of 4,000 Kansas City residents. And what you do is you send each individual a survey by mail, and you call each of them to try to maximize participation. Suppose that of these 4,000 people, 350 of them responded to you. They either responded to your mailed survey or to your phone call. What do you think about the data you are going to gather from this? So maybe like 300 of these people supported this motion and the other 50 didn't. So a vast majority of people supported this of those that responded. Right? Do you think that you can trust that data? Do you think that you can now conclude that the majority of the overall population would support such a thing? The answer is no. Okay, this survey suffers from what is called non-response bias. Notice that of the 4,000 people you asked, only 350 of them responded. And so again, these 350 people, they probably either feel very strongly, they probably either strongly support the motion or strongly don't support it. So you're probably just getting extremes from those people. So the response rate was low. When the response rate is low, you have what's called non-response bias. You can't really trust the data from such a survey. You're hoping that all 4,000 of these people were chosen well, and that they will all respond to you, right? But if they don't, if you have a low response rate, then there's not much you can do with that data. Here is another type of sampling bias, quota sampling. It's a systematic effort to force the sample to be representative of a given population through the use of quotas. Here's how it works. Suppose that you know before you even start your study that the population you are studying is 52% women and 48% men. Then you might think to yourself, well, when I create a sample, I should make sure that 52% of my sample is women and the other 48% are men. Or suppose you know ahead of time demographic breakdowns like this of your population. You know that 30% are white, 45% are black, 25% are Hispanic. Then you think to yourself, okay, when I make a sample, I should make sure that 30% of my sample consists of white people, 25% consists of Hispanic people, etc. So again, when you're doing quota sampling, you are forcing your sample to look like the global population. You are trying to force your sample to be representative, and you're doing that by using quotas. Okay, so the title of this slide is sampling bias. So presumably there's something bad about this. Now when I ask students in class if they think there's something wrong with this, many of them say no, I don't see anything wrong with this. We want a representative sample, don't we? Right? We want a sample that looks like the overall population. So why don't we use quotas when we're choosing samples? It seems like a good way of making our sample look like our overall population. So quota sampling, unlike the previous types of bias sampling we've seen, it's actually not easy to see what's wrong with it. I mean, things like, self-selection bias or convenience sampling, it's pretty easy to see why the data you get from that might not be reliable. But it's less clear why using quota sampling will produce data that's unreliable. And the main reason why quota sampling is bad is because of this question here. On the previous slide, we had quotas based on race and gender. But where do you stop? Like suppose you make your sample look like the racial makeup of the global population. Well, then after that, I suppose you would have to worry about gender. Like suppose that you make your sample look like this to match the global population. Maybe your sample doesn't satisfy this condition though. I mean, maybe you make it racially the same as the global population, but doing that means that you didn't quite make the genders line up. Well, now you got to make the genders and the races line up. And then once you're done with that, you think, oh, well, I want to have representative income levels. So I got to force my race and gender breakdowns to now match the income distribution. And I want to make sure I have a wide range of education levels that match the population, right? And I want to make sure that sexual orientation matches up. So if 5% of my global population is homosexual, I want to make sure that 5% of my sample is, and so on. Okay, there are many, many, many more variables than these that you might want to make quotas based on, right? Race, gender, income, education, sexual orientation, left-handedness, eye color. I mean, who knows? There are all sorts of ways you could define quotas, and then you would have to fill them based on what the global population breakdown is. But you can't really do this. It's practically impossible to make all of your quotas line up with all of the others. So in practice, this is bad. If you make your racial breakdown look like the global population and you force that to happen, then you've probably missed out on some other of these variables here. Okay, so let me now return to this example that I started with. 67% of Kansans support legalizing marijuana while 33% oppose it. This is a real survey. It's a real survey that I got online. And the way it worked was, it was just a website that asked, are you a Kansan and do you believe that marijuana should be legalized? And that's it. And you could respond. So such a site has numerous problems. First and foremost is convenience sampling. The people who set up that website just set up the site and then they let it go. It's very convenient for them. It's cheap to just set up a site, and it's convenient to set up a site and let people respond. It suffers from self-selection bias because people can choose whether or not to be in the sample. And it has other problems that we haven't talked about, like this particular survey has no way of checking whether or not you are actually a Kansan. Okay, I am not a Kansan, but I did vote in this poll. Okay, and it took my vote. So, things like this, the data that you're going to get from something like this is totally useless. When you have convenience sampling and self-selection bias and whatever else, you can't make any inferences based on this data. It's useless. Okay, so we've talked about bad sampling. Let us now talk about good sampling. The best alternative to human selection, so things like quota sampling, convenience sampling, etc., is to let the laws of chance determine who gets to be in the sample and who doesn't get to be in the sample. So basically we think to ourselves, human beings are bad at choosing samples. So let's take the role of choosing out of the hands of people and let the laws of probability or the laws of chance determine who gets to be in the sample. The most basic form of random sampling is called simple random sampling. it's based on the same principle as a lottery. Okay, in a lottery, human beings don't choose the winners, right? We randomly choose little balls with numbers on them, right? So the laws of chance determine who the winner is. So simple random sampling is based on the same principle as a lottery. So if I'm going to choose a sample of 50 people out of 200 people, just imagine writing 200 names on slips of paper, putting them in a hat, mixing them really well, and then choosing names out of the hat. Right? That's what simple random sampling is. Simple random sampling is the gold standard. In practice, it's very hard to achieve, especially for large surveys like national ones. So national surveys and polls use what's called stratified sampling. This is considered good sampling as well. It's considered good, like simple random sampling is considered good. It will choose a representative sample. So it's not quite as, like if you could do simple random, you would do simple random. It's not quite as good as that, but it's still good enough. So here's the idea of stratified sampling. You break your sampling frame. Again, this means where you draw your sample from. You break your sampling frame into categories, and the categories are called strata. You randomly choose a sample from those strata. You divide each of those into substrata. So you have categories of categories here, and you randomly choose some of those. Then you take those subcategories and divide them into like sub-subcategories, and then you randomly choose some of those. And you keep going for as long as you want, usually 2 or 3 more steps. And at every point in this process, you are randomly choosing things, so you'd never resort to quotas or anything like that. This is cheaper and more efficient than simple random sampling and has generally proven to be a reliable way to collect data. So we sort of empirically know that stratified sampling is good. So this idea here probably isn't clear at all, so let's now look at an example. In national polls, the categories themselves are usually defined by a combination of geographic and demographic criteria. The first category, or the first layer of strata, however you want to say it, is usually size of community. So you have big cities, medium cities, towns, villages, etc. Okay, so what you're going to do first is randomly choose, let's say, 2 of these off of this list. So let's just say that there are these 4, right? There are more than this, but these 4 options. What I will do is I will roll a 4-sided die, essentially, a couple of times. And let's say that if I roll a 2, I choose medium cities. If I roll a 3, I'm going to choose a town. So essentially, I'm just randomly choosing from this list right here. So maybe on my first step, I decide, okay, based on the randomness, I'm going to sample from medium cities and towns. And then the next category is maybe geographical region. New England, the Middle Atlantic, the Midwest, etc. So again, you would randomly choose some of these off of this list. So maybe you randomly choose New England and East Central. Okay, so now that means you're going to look at medium cities and towns inside of New England and East Central. And then within each of those geographical regions and within each size of community, usually you'll choose community size. Usually you'll randomly choose certain neighborhoods or certain communities. So that's your third layer of strata or your third layer of categories, etc. Okay, so as I say here, see example 14.10 for a complete description. Almost any national poll that you see quoted on the news was done like this. They don't do simple random sampling as it's usually defined. They use stratified sampling. Okay, and that is the end of section 14.2.